Hi, I'm at Southend-on-Sea today. You see behind me, Southend Pier, just the end of the pier, just up there. I found lots of shells on the beach. Oh, huge amounts of shells here. These shells are all made of carbon, largely made of carbon. It started me thinking about the way the carbon is moved around, is cycled by the ocean. So let's have a think about today and talk about the physical pump, the carbonate pump, and the biological pump.
Okay, let's start with a bit of background. The ocean absorbs huge amounts of carbon, 50 times more in fact than the atmosphere. The sea surface basically absorbs and releases carbon dioxide, and once it's in the sea it can be absorbed into the marine ecosystem from there, and sometimes it can make its way down to the seabed.
Okay, so let's break this down a little bit, and we start off by looking at a thing called the physical pump. So this diagram we've got here shows us the ocean where the atmosphere is above it. On the left we can see the equator, and on the right we can see either the North Pole or the South Pole. Doesn't matter which one. The circular motion you can see in the ocean represents the ocean currents, which are driven by a thing called thermohaline circulation. This just means that the ocean water is circulating due to variations in heat, which is the thermo bit, and salt, which is the haline bit. Now, starting at number 1 on the diagram, which you can see in green there in the middle, so the thermohaline circulation, it moves surface water away from the equator, where it cools down and it starts to sink, and it takes the carbon with it that it had absorbed while it was at the surface. And then the oceanic carbon goes down where we've got number 2 into these deep ocean stores. It stays there for a period of time, eventually coming back to the surface where, as you can see, numbers 3 and 4, where this deep cool water is going to replace the warm surface water, often close to the equator, as that warm surface water is going to be pushed away towards the pole. Okay, and then at number 5 we can see then we have that exchange of carbon. So the carbon that's been stored deep in the ocean for maybe 1,000 years is going to be released into the atmosphere, and then different carbon is going to be absorbed back in. So via this we can see that there is this kind of long to medium term storage of carbon around about 1,000 years. Now the balance of this, the problem we've got perhaps, is this is being disrupted. The balance is being disrupted through anthropogenic or human-induced climate change. So we've got the ocean as a storage of carbon slowing down due to there being more carbon dioxide in the ocean, which ultimately is of course derived from the atmosphere. So as the ocean becomes more acidic, meaning it's got more carbon in it, that is going to reduce the sea's ability to dampen the effects of climate change. Okay, so let's now look at the biological pump. Now this involves the dissolved carbon, which we just explained via the physical pump, being absorbed into the oceanic biosphere, which is one, the phytoplankton, which photosynthesize and absorb the carbon that way into the ocean, or secondly, the animals like the fish bones and the lobster shells. So via this system, the carbon continues to be locked away or sequestered, or locked away, for a period of time in the ocean. And this moves us into the bottom half of this diagram, which shows us the carbonate pump. So some of this biological material, like the shells maybe, are going to build up on the ocean floor. And along with the other bits and pieces that make their way down there, will form carbon-rich sediment layers. Over time, these undergo chemical and physical processes and lithify or become rock. Once the carbon reaches this point, it might be locked out of the atmosphere and locked away or sequestered for maybe hundreds of millions of years, perhaps until it is subducted and the carbon is then perhaps outgassed from a volcano.